Hi. So today we are starting with the idea of covalent bonding. What it is, what it's not. The key ideas remain the same, that electrons are being shared, and usually that happens between non-metals, but that's not always the case. That's usually what happens. There are cases where metals share electrons with non-metals, and one example of that is aluminium trichloride. And usually we get hints based on what the properties of these compounds are, if what kind of melting point, boiling point, conductivity, these kind of things, whether they're hard or soft and all that. And they're all hints for us to know what kind of bonding is actually inside. So let's get started with this worksheet. Question number 1 says, in order to form a compound with oxygen, an atom of group 2 element must. Now group 2, as we know, this is actually a metal. So because you have a metal here, what must a metal do? Usually what a metal must do with oxygen, which is a non-metal, it is that it must transfer electrons. So if it transfer electrons, then we know that this is actually an ionic bonding happen, which means this is not covalent bond right away. So we will be looking for where they transfer electrons, and because it is group 2, it must have 2 electrons in the last shell, and oxygen is in group 6, so it needs to gain 2 electrons, and that is how they will transfer 2 electrons to an atom of oxygen, and our answer would be A. Now question number 2 says, which molecule contains 3 shared pairs of electrons between 2 of its atoms? So what we must do is that we must draw the Louis diagram for this, the structure of these. So the first option is carbon dioxide, which is basically carbon sharing 2 electrons with 2 oxygen. And then we have C2H4, which is again something like this, where you have hydrogen here, and same case on this side. And then you have water, which is like this, a classic molecule. And then you have nitrogen. So nitrogen, which is in group 5, it's going to share 3 electrons with the other nitrogen, and that is also going to share 3 electrons, and that is how they get 3 shared pairs of electrons between these two. So our answer is going to be nitrogen. A molecule of sulfuric acid has a structural formula shown. Now you can notice that sulfur over here has 12 electrons in the last shell when it's sharing, but that's fine. We don't need to actually go into the details of why that happens, and you will not be asked to draw this structure if it ever comes. They will give you the structure and ask you questions according to that. For example, this question says that how many electrons are involved in forming all the covalent bonds. Now for that, you are just trying to understand what this line means. And you know that this line means one pair that is shared. So we have 1, 2, 3, 4, 5, 6, and 7, and then 8 total bonds. So that is 8 times 2, 16 electrons involved in bonding. Question number 4 says a covalent bond is formed by, so that is according to the definition of covalent bond, how it is formed is that it is electrons being shared between non-metals usually. So that is the case here, so we are going to pick B. Which pair of elements when combined together do not form a covalent bond? Again, it's according to the previous definition. We are looking for 2 non-metals trying to share electrons. So the one that involves metal or metals, that will not be our answer. So that is actually option number A, because it says cesium, which is a metal, and definitely it will transfer electron to fluorine. It will not share. Nitrogen, chlorine, both non-metals, they share. Phosphorus and fluorine, they both share. And sulfur and chlorine, they both non-metals are, so they will be sharing. All right. Question number 6. Which diagram does not show the outer shell electron in the molecule correctly? Now what you have to remember for this is that while atoms share electrons, there are some electrons that are not shared, and we call them lone pairs, and they are important. They are important for the structure, they're important for chemical properties, which is why you must show them every time you draw any diagram. Now in this case, if you look at molecule D, then you will see that chlorine needs 3 lone pairs. There are 6 electrons of chlorine that are not shared, and the chlorine on the left in here, that hasn't shown this. So there is actually 6 electrons that are missing, and that is why this is not the correct picture, and our answer is D. In every other one, carbon has 4, so 4 are shown. Hydrogen has 1, 1 is shown. Chlorine has 7 of its own, so they are also shown. So we need to show the electrons for chlorine, which is why option D is wrong. Question number 7 says there's statement 1, 2, and 3 about diamond and graphite. They're allotropes, that's a key term here, and they're both carbon but different structures of that. They're different solid forms of the same element. Yeah, that is true. That is true because they're both carbon and they're allotropes of that. They each conduct electricity. That is not true for diamond, but graphite does, so this statement is wrong. And they have atoms that form 4 equally strong bonds. So that does happen, but not in graphite, because graphite has 1 electron that is free, so that is not part of a bond that is that strong. In the case of diamond, that is true. So again, this one is wrong for graphite. Which statements are correct? So because the question was saying they are about diamond and graphite, this and word here means that we cannot just pick the one that is only true for one of them. So we'll say that only one is true. Question number 8 says the diagram shows the structure of two forms, P and Q, of solid element. Most likely this is carbon because P is just like graphite and Q is just like diamond. This you can see is layers, and these layers obviously make it soft, and because of this being soft it is useful as a lubricant. But this one has a tetrahedral network or tetrahedral structure which is very rigid, very difficult to move these atoms, which means this will be quite hard. So because of these layers, this thing is soft and this thing is hard, and because this is soft you can use it as lubrication, and that one you can use for drilling. So that means our answer is B, which is our answer here. The lead in a pencil is made of mixture of graphite and clay. If the percentage of graphite is increased, the pencil slides across the paper more easily. What does this mean? When it slides across the paper more easily, that shows that this is more soft, and that is again because graphite is a lubricant. Now other statements might be true for graphite, like graphite conducts electricity. That's true, but how does that relate to it sliding or it being more soft? Or it is a form of carbon. It was a form anyway, and it's a non-metal. It was a non-metal anyway, whether you increase the percentage of graphite or not. The pencil sliding across more easily, that is a hint that it's a lubricant, and because of that we can use this for that because it's soft. This shows that pencil lead and lubricants have a shared property, that they both need to be soft, and graphite fulfills that property. So that is why it's useful for both of these. Question number 10 is about the following statement. The covalent bonds are formed by dash of electrons. So that is, we know, sharing of electrons. And covalent substances have, I don't know, is it bad? Is it good? It depends on what charged particles they have, and usually covalent substances don't have free charged particles like electrons or ions that are usually non-existent there. So we'll say that they have low electrical conductivity, or graphite might be an exception. So that is why our answer is B. And that brings us to theory questions. Carbonyl chloride has a structure shown below. Now again, this is a molecule that we usually do not see in O levels, but that doesn't matter because we will never be asked to actually come up with this bonding for molecules that are very different from the ones that we usually draw. Sure, there might be ones that we do not draw but are similar to the ones that we do. There are 9 molecules that are in your syllabus, so make sure that you are able to draw all of them. Now it says that draw a diagram to show the arrangement of only the outer electrons in one molecule of carbonyl chloride. Now what they're actually asking you is, do you understand what this line means? And we do. It shows 1 electron being shared, and that means that we also need to know what these 2 lines mean. They mean 2 electron pairs being shared. So let's start with this. We'll have to just make a copy of this one, but instead of putting lines we will do circles. So carbon here, so there's a circle for carbon, and there's oxygen which is sharing electrons, so there's a circle for that, and there's chlorine which is also sharing electrons, so there's that, and there's chlorine which is just like this one. So notice that my shape of molecule is just like the one before. Now I'll start putting electrons. Now I know that carbon has 4 electrons, so there you go, 4 electrons for carbon, and depending on what kind of bonding it has, I've put them electrons there. And then I will put the electrons for chlorine. Chlorine has 7 electrons, 1 of them being shared. Notice that I'm using a different shape. Dots or crosses are the ones that you can use. So I'm going to use a dot for this, and 7 electrons but one being shared, the other 6 must be shown. So there you go, the other 6 are over here. Same for the other chlorine, other 6 outside and one being shared. And for oxygen, I have 6 electrons in total, 2 of them being shared and the other 4 outside. And there you go, we have completed the diagram. Explain why carbonyl chloride has low melting point. Now again, you know that this is a molecule, right? So whenever you have a molecule, so for example, if I have one molecule and I have another molecule, they will have a very weak intermolecular force of attraction. So this weak intermolecular force of attraction is the one that is keeping these molecules close to each other. And because it's weak, this is the key word here, that this is weak. And because it is weak, you can easily overcome this force by applying a very low amount of energy. And that is how it relates to the low melting point. तो जब भी इस तरह के क्वेश्चन को आपने आंसर करना है, you have to remember that sure, at the molecular level, you have weak intermolecular forces, but just saying that they have weak intermolecular forces doesn't quite relate melting point to that. So there is a link. The link is that you will supply more energy if it was stronger forces. So that's the case here. We'll say that why does it have a low melting point? That the molecules have, you don't need to name the molecules if you don't want to. So molecules have weak intermolecular force of attraction. So you can write the whole thing. Don't write IMFA or some other acronym because examiner doesn't know that. So intermolecular forces of attraction. It's better to explain the whole thing, which are easily overcome or which are easier to overcome with a small amount of heat or at low temperature or something like that. Okay. Yep. Electrolytes are liquids that conduct electricity. Do you think carbonyl chloride could be a good electrolyte? Now here's a definition that examiner has given you, and this examiner should be useful in this question. So जब भी आप answer करने हैं, pay attention to what data they're giving you. Do you think carbonyl chloride would be a good electrolyte when molten? Why or why not? So what they're saying is that now that you know electrolytes are liquids that conduct electricity, do you think this carbonyl chloride? And you need to recall that for anything to conduct electricity, what you need is charged particles, and not just charged particles, they must be free. So that is the important thing here. There must be charged particles that are free. Do we have them in carbonyl chloride? We don't. So that is why we'll say that it will not be a good electrolyte. So we don't expect it to be. No, just writing no is enough. You don't have to explain the whole sentence. And the reason is that it does not have any free electrons. Again, write the whole thing. But examiner does accept if you just write E. Any free electrons, put a negative charge on there. Any free electrons to carry electricity. So there you go. This does not conduct electricity because it doesn't have any free electrons. All right, let's look at this question. Graphite and diamond are two allotropes of carbon. Define the term allotrope. All right, so we know that allotropes, there are three main things in there. So you have to understand that all three are important. So first of all, they are different structures of same element in same state or phase. So three main ideas here. Number one, they are different structures. That's the difference. But they are the same element. That's the common thing. And they have to be in the same state. That's the third common thing. So they should all be solid or they should all be gaseous in the case of oxygen and ozone. So that is why in the case of graphite and diamond, they're both solids, they're both carbon, but they're different in structures. So that's what makes them allotropes. Explain in terms of its structure why graphite is soft and a good conductor of electricity. So the question is not about diamond, so you should not discuss diamond in there. So graphite is soft. Let's talk about that part first. So there are two parts to this question. Why is it soft and why is it a good conductor? So let's talk about graphite being soft. So we'll say that graphite has layers of atoms or has layers which can slide. So it is soft. You can also talk about how layers have weak forces between them, but don't use the word intermolecular because these are not molecules. And the second one is why is it a good conductor? So we'll say that each carbon atom, just writing C is enough, has one free electron. So just writing E is enough, or if you want to write the whole thing. So one free electron which can conduct electricity. So if we have answered both the requirements of the question, that why is it a soft thing and why is it a good conductor. State two uses of graphite which depends on the above properties. So the first one is that when is it soft, where you can use it. So just writing this word is enough. Why? Because again the command word here is state. So you don't need to give a reason. So you'll just say it is soft. So yeah, we can use it as a lubricant. It's a good conductor, so we can use it as an electrode. It is actually used for both of these things. And you don't need to give a reason or give an explanation or detail of this because the command word was just state. State two physical properties of diamond that are different from graphite. So for physical properties, you have to talk about melting point, boiling point, solubility, and conduction. Color is a chemical property. So you cannot say that graphite is black while diamond is colorless because it's a chemical property. So two physical properties of diamond that are different. Number one, it has a higher melting point. Okay. And second, it does not conduct electricity. So just writing this is enough. You don't need to give a detail of why this is or the reason and anything. That's not really required. So there you go. We have talked about why some things conduct electricity, why some things do not conduct electricity, what is special about molecules, intermolecular forces. We have talked about uses of diamond and graphite, which is a very common question. So that brings us to the end of this worksheet. I hope you understand this. Feel free to go through more past paper questions so that you fully understand them and review your notes. All the best. Thank you so much.